We're going to start grade 11 maths today. Hopefully you'll be with me through the series, and we can start the process. As I've said before, if this is your first time joining, please do remember the whole objective of this is that you've got notepad, you've got your calculator and everything with you, and as we work through the problems, start it, rewind it, so that you've got the solution to a problem. The whole purpose of this is that you get a set of solved problems plus the recipes that go with it. And you've worked through them. Please make your own notes. That's important. Remember, it's not just what I say, it's the way you want to record that. That's a critical part of this as well. It's not just about me, it's about you. And in essence, please make the most of these. You know, it's really critical that we, over the whole world, build up skills in maths, in chemistry, in physics, and many other things. But obviously, those are some of the cores, was the ones I'm passionate about anyway. So let's begin. We're going to start with surds and exponents. If you remember previously, and if you did grade 10 with me, essentially what I did is I had two separate ones. Okay, I said that there's two types, right? There's the general type, okay, which I like that, and then there's another type, which I like that. I'm going to give you an example of each. This is, for example, they say simplify. 12 to the power of x plus 1 multiplied by 27 to the power of x minus 2. All right. The other side was 3 to the power of 2x plus 3 to the power of 2x plus 1 over 9 to the power of x minus 3 to the power of 2. I was thinking of a series there. 2x plus 2. Okay, right. This one was also divided by 18 to the power of 2x minus 1. All right. This is, let's say, type A, and this one, type B. Spot the difference between them. The one is a straightforward series of terms on top, which you've got multiply this by that, multiply this by that. Could have a whole string of them, right? In that, and we've got a denominator, so we're going to divide by something. In the next series, we had this. Can you see? Separated by plus and minus signs. The key here, right, is essentially the recipe is the same for both. It's the same as the one we did last year in grade 10, all right? But it's also going to be the same for this. What do we do first of all? Well, step one is put it into prime factors. Step one is prime factors, right? And this is the same, we're going to do the same thing for when we get to exponential equations. We're going to do exactly the same thing. It's not going to change. So the recipe, the secret, once again, I know I shouldn't be telling you, but write it down and then apply it to the ones we've done. And then apply it to some of the ones that are in your textbooks with answers, and you'll see the recipe works, okay? Well, it should. I mean, it's what it's there for. But let's have a look, prime factors first. So we have to write 12 as prime factors. By now, many of you have got the calculator that will give you the factors, okay? It's got the FACT buttons on them. Those of you who don't, you can always go back to this, right? 2 in 12. 2, remember we only go with prime factors there, right? Remember? So we've got a 2s, 3s, 5s, 7s that we're going to try with. 2 into 12 is 6. 2 into 6 is 3. So therefore 12 I can write as 2 squared times 3. Okay? To the power of x plus 1. And I'm going to multiply that by 3 to the power of 3 to the power of x minus 2. Okay? And 18 we're going to write is 2 times 3 squared to the power of 2x minus 1. What are we going to do with this now? Well, now step 2 was remove brackets. Remove the brackets. Okay? Well, I'm not going to do this one concurrently, but we'll get back to him. When we remove the brackets, we mean remove these brackets here and all over, right? Here's where the big mistakes happen. We must multiply it out. Bracket means times, therefore it's 2 to the power of 2x plus 2 times 3 to the power of x plus 1, multiplied by 3 to the power of 3x minus 6, right? All over 2 to the power of 2x minus 1, 3 to the power of 4x minus 2. Okay? Basically, there you go. That's a source of error. So be careful when you're multiplying it out. Make sure you multiply every term in what's above. Remember, it could be a quadratic of x squared minus 2x plus 1 on the outside of the bracket that we have to multiply out. Just make sure you multiply each and every term by the exponent inside the bracket. Okay? Let's go further now. Now we say, okay, remove the brackets. The next step, step 3, is split. What do I mean? I mean split them up like this. 2 to the power of x, 2x, 2 to the power of 2, 3 to the power of x, 3 to the power of 1, times 3 to the power of 3x, 3 to the minus 6, all over. Let me make that a minus 6 clear. 2 to the power of x, 2 to the minus 1, 3 to the 4x, and 3 to the 2. Okay? I split them there, right? Remember, 2 to the power of 2x, for example, 2 to the power of 2x minus 2 is actually equal to 2 to the power of 2x times 2 to the minus 2. Why? We add the exponents if the base is the same. Remember that? We add the exponents if the base is the same. All we're doing is we're reversing the process, and just for completeness, we never leave it with a negative exponent. So that is 2 to the 2x over 2 squared, right? Okay, I'm going to erase that. 2 to the 2x over 2 squared, right? Let's just get rid of that because it's going to be in the way when we continue with the next one anyway. All right? Okay, let's just, make sure. Now, what can we do next? Next, we split, okay? Then I personally like to do the following. Make any negative exponent positive. So if it's negative on top, it must go underneath and become positive. If it's negative at the bottom, it goes to the top and becomes positive. What do? I draw my line and I say, okay, you are 2 to the 2x, 2 squared, 3 to the x, 3 to the 1, 3 to the 3x, and there's a 3 to the minus 6. So that goes down and becomes 3 to the 6 at the bottom. Okay? Then we say, okie dokes. Then at the bottom, we had a 2 to the 2x times, we had a 2 to the minus 1. So the 2 to the minus 1 must go up and it becomes 2 to the plus 1. 3 to the 4x. Okay? And we had a 3 to the minus 2. So the 3 to the minus 2 goes up and it becomes 3 to the 2. Okay. The next step, okay, if you like, you can group like terms or you can just start to cross cancel straight away. It's your decision. A lot of people like to group like terms. It's actually the best idea is to group the like terms, but you can cross cancel straight away like this. Okay. We say start always over there. 2 to the 2x cancels. There's 1, right? 2 squared can cancel with nothing underneath. There's no 2's. 3 to the x, yes, we can cancel that. With that leaving 3 to the 3x, correct? Then we've got 3 to the 1, okay? And that 3 to the 1, okay? 3 to the x has gone there. The 3 to the 1 can cancel with this guy, leaving us with 3 to the 5, right? And then we continue. 3 to the 3x, okay, is over there. Oh, it cancels completely with that one. Okay, 2 to the 1, okay, basically stays. 3 squared is going to cancel with that, leaving us with 3 to the 3 at the bottom there, okay? So what do we end up with? Now, let's see what's left over after our after our cancellation process, what have we got? Okay, we've got posit like that, and then cancel. Okay, we have got on top 2 squared and another 2. So on top we've got 2 squared, 2 to the 1. At the bottom we have got 3 to the power of 3. My final answer is thus 2 cubed over 3 cubed. All right, you could write that as 8 over 27. It is also the same as 2 over 3 all cubed, isn't it not? Is it not? Okay, let us continue now with this guy. Okay, what did we say? We said prime factors. Well, 3 is already prime, so we don't have to worry. So it's 3 to the 2x can stay, and our 3 to the 2x plus 1. And it, oh, hang on, there's 1. We say this is a plus there. We say that is 3 squared to the power of x minus 3 to the 2x plus 2. Next step is I must remove brackets. So let's do that. So we've got 3 to the 2x on top plus 3 to the 2x plus 1 over 3 to the 2x minus 3 to the 2x plus 2. The next step we said was split. Let us split. Nothing to split there, so leave it. 3 to the 2x plus, split out here. 3 to the power of 1 over 3 to the 2x minus, yep, there's something to split, 3 to the 2x times 3 squared. What am I going to do next? Next I am going to do, what did it say? Here's the extra step. I'm going to put it in red. Extra step to the recipe. Because there's a plus minuses between the terms, you need to factorize. Because it's going to cancel out at the bottom, right, or the top. Let's have a look. What is common on the top is 3 to the power of 2x. So remove it. Leaves us with what times that must be that is a 1 plus 3 to the 1. Just leaves us with that. The bottom, 3 to the 2x again. Leaves us with a 1 minus 3 squared. Okay. These generally all work out to be the same. Then we say, right, look, cancel out. Let me get my green cancel pen. Green, there we go, there we go, there we go. Leaves us with at the top, 1 plus 3 to the 1 over 1 minus 3 squared, which is going to be 4 over 1 minus 9. My final answer is 4 over minus 8, which is minus a half. Okay. So you've got the same set of recipes. Okay. It's the same process. We're just going to go through it. Even when it comes to what I'm going to do is I'm going to do an exponential equation next. I'm going to do the exponential equations. You're doing exactly the same thing, right? Where we're going to go through and we're going to do one where it's just times and that, and then where we've got a plus and a minus on the other side. Okay, so let's have a look at an exponential equation, shall we? Okay, I'm going to do first of all type A. Remember, this is the one with no plus or minuses between the terms. It's just terms multiplied by each other. Okay, an exponential equation, what is it? Well, first of all, let's just recap what an exponential equation is. It is something where the x is in the exponent. In other words, you have something to the power of x. X is up here. Okay? X is up there. Okay? What did we do? We said, let's say we had 2 to the power of x minus 2 equals 8. What did we do? We said, okay, that is 2 to the power of x. Split it, 2 to the minus 2 equals 8. All right? And you could take that to the other side if you wish. The other way of doing it is to say, hold on, I haven't prime factored that. So let's first of all look at it doing it this way. Let's say 2 to the power of x minus 2. That's going to be 2 cubed. And look what we've got. We've got the base the same, which means we then say x minus 2 equals to 3. So x is equal to 5. We're essentially getting the base to be identical. All right? We are going to do some where they're a little more complicated, but let's start with one this type. 16 to the power of x plus 1 is equal to 64 over 8 to the power of x. Wow, that looks quite hairy. Okay, let's see. Prime factors. Step 1, prime factors. Okay, let's see if my recipe holds. First of all, prime factors. 2 is going to be 2 to the power of 4. Okay, like that. X plus 1 is equal to 64, 2 to the power of 6 over 2 to the power of 3. And there's my x there. Next step, 2, remove brackets, remember? So that's going to be 2 to the power of 4x plus 4 is going to be equal to 2 to the power of 6 over 2 to the power of 3x. Right. Now, let's have a look. Well, I say, first of all, I'm targeting to get the base the same. Okay. Now, let me just move this thing up a little bit so that we've got space. So we say, okay, can you see here? Let us put it all on one line. 2 to the power of 4x plus 4 is going to be equal to 2 to the power of 6 times 2 to the minus 3x. This is then 2 to the power of 6 minus 3x is equal to 2 to the power of 4x plus 9. Now what have I got? I've got bases the same, which means drop the base. So basically, we're going to do that situation, we're going to just drop the base now. Okay? Because if it's equal and the bases are the same, you can drop it. So it's 4x plus 9 is going to be 6 minus 3x. Take it across, you get 7x is equal to 6 minus 9. Okay. 4x plus 4. Wow. I really, look how my 4 changed. Plus 4, plus 4, plus 4. So that's going to go to the other side. 6 minus 4 is equal to 2. So therefore x is equal to 2 over 7. All right. And how do we check if we're right? Put x equal to 2 over 7 in there. And then just check that you get the same answer. Look at the next one. The next one is slightly different. It's 2 to the power of 2x. Let's have a look here. It's 2 to the power of 2x minus 4 to the power of x plus 1. Okay, equals minus 24. All right. Well, let's just first of all say, what are we going to do with this? Well, first of all, let's prime factor it. This is 2 to the power of 2x minus 2 to the power of 2, brackets, x plus 1. This here, all right, let's just leave that for a second. Or, if you wish, you can prime factor it. But I'm just going to leave it for a second because I want to show you that the moment you see a 2x, all right, be attuned to the fact you're going to get a trinomial, a quadratic, all right? Guaranteed. Well, not guaranteed, but most times you're going to get this. So let's have a look here, okay? What do I do next? I remove brackets. So I've got 2 to the power of 2x minus 2 to the power of 2x. Okay, 2 to the power of 2x. Okay, plus 2. Remember, equal to minus 24. This is 2 to the power of 2x minus split. Remember, here's the same thing. Okay, let's have a look here. Prime factors. Okay, remove brackets. There they go. Split is here. 2 to the power of 2x. 2 to the power of 2 equals minus 24. What do? I've got pluses and minuses. Factorize. In here, we can take out 2 to the power of 2x out because it's common in both sides. Therefore, I'm left with what times that is a 1 times that is 2 to the power of 2x minus 4. Therefore, 2 to the power of 2x times minus 3 equals minus 24. Okay. And now we're nearly there. 2 to the power of 2x is equal to minus 24 over minus 3 is 8. That's a simple, straightforward 2 to the power of 3. So therefore 2 to the power of 2x. Drop the bases now. 2x equals 3. Therefore x is going to be equal to 3 over 2. And you can back substitute in to find the answer to that one. So in essence, what we're trying to do here is we're trying to get to the answer of x, obviously, but can you see there's two different types? So when you've got one with pluses and minuses in it, and when you've got one with no separation of terms, you go through them in the same way. The only difference is where we are going to factorize. We have to factorize in the 1, okay? The next step is let's look at surds, right? Surds, remember we had the whole long thing on a surd. A surd essentially was the square root. We don't write the 2 in there. So basically it's something with a root sign. It could be the nth root, right? Which means if I rewrite this, this is equal to whatever's in here to the power of a half. So this is going to be equal to whatever's in here there to the power of 1 over n, all right? Then when we've written it like that, we can multiply that into the bracket as per normal. Can you see the recipe coming back again? Okay. What we have to do is with a surd equation, all right, just check that we're on the right color here. With a surd equation, all right, what we've got is we're going to say, let us say we've got this. The cube root of x squared is equal to, now let's just simplify this. Therefore, that is x squared to the power of 1/3, which is equal to x to the power of 2/3, correct? We're going to deal with exponents and surds interchangeably because essentially we can take a surd and we can make it into an exponent. What we're going to do is we're going to go and we're going to simplify first, then we're going to put it into an equation. Okay? And we're going to have the x is an unknown is in the base here. So we're going to be working with x as a base. Right? Okay. So let's start off. Let's say we have something simple. X to the power, or let's say root x equal to 9. How do we solve for x? All right. Well, we're going to have to, let's take the root and make it a power, an exponent. This is x inside, whatever's inside, to the power of a half is equal to 9. Right? So what are we going to do next? The next is we don't want that half. We are going to raise it to the power of, again, 2 over 1, and we do it on both sides. Right? Which means, let's have a look. Which means what? It means here, x to the power of a half, let's take it properly, that's going to be multiplied by 2 over 1 is equal to 9 to the power of 2. Our half cancels with that, ending us with x to the 1 is equal to 81. Therefore, we have found x to be 81. Okay. Let's just do a different thingy. Let's say we've got x to the power of minus 2 over 5 equal to something. Never mind what it is. Let's just go. What do? We first of all, we say, okay, we want x to the 1. So we have to find what are we going to multiply this by to change it to 1. The answer is a minus 5 over 2. So then we're going to take something on this side, and we are going to raise that also to the power of minus 5 over 2. That must be the same. So we've used the exponent, right, to cancel out on the left-hand side. In other words, leaving us with x to the power of 1 equal to something to the power of minus 5 over 2. Now, depending upon what it is. In some cases, you'd put that into a calculator and put to the power of minus 5 over 2, and the calculator will give an answer back to you. So what we're doing in Surds, I'm going to do a few here. All right, let's have a look at this. Okay, exponential problem. Right, we've got here the cube root of x squared equal to 9. Right, now what I'm going to do, okay, is I'm going to say, first of all, I need to change this side. This is going to be x squared all to the power of 1/3, and this is going to be 3 squared, right? Prime factors again. You can see prime factors are coming in often. So what do? We say righty-ho. I've done it here. Okay. Let's multiply out. We end up with x to the 2/3 equal to 3 to the power of 2. Okay. Now I've multiplied. At this stage, I'm putting it in red. Check. Positive exponents in the numerator. If you've got a positive, a 2 or a 4 in the numerator, you have to have a plus and minus solution. Right? Because why? Well, it's very simple actually. What are we doing? We are saying that x squared is equal to some number. There it is. Can you see? There's the x squared. It could also be x to the 4th. X squared is equal to that number. How do we find x? We take the square root. The moment we take the square root, we get a plus or a minus number coming out, don't we? If it was x squared is equal to 9, we would have x equal plus or minus 3. If we had x to the 4th equal to something, we're going to get a plus and a minus when we take the 4th root. Because minus 2 times minus 2 is going to give us plus 4. So is 2 and 2. Minus 2 times minus 2 times minus 2 times minus 2. 2 to the 4th, 8, 16, right? It's going to give us a plus or a minus. So when you have a positive exponent in the numerator, okay, after you've done all this, at this stage here, you do this check here. That tells you now, from now on, you have to put a plus minus sign in. So we say, right now, x to the power of 2/3, okay, I'm raising that to the power of 3 over 2. The power of 3 over 2, okay, is going to give me equals, right, plus or minus 3 squared to the power of 3 over 2, which is going to be plus or minus 3 cubed, which is going to be, okay, plus or minus 27. Okay? Quite straightforward. Okay? When I come back, we're going to do some more examples, just another one of those, where we'll have a look where we've got a positive exponent as well. Okay? In the next one, we're going to continue, as I say, with that. I'll see you in the next one. Please go through those. Go through the recipes, right? Prime factor it, if you can. If it's prime factored, expand the brackets. Do the split. Factorize if it's got pluses and minuses. Otherwise, make sure you get all your negatives to positives and then start the cross cancel. When you do the cross cancel, one last thing, I know I talk too much. One last thing when you cross cancel, if you've got, say, a 12 over here, 12, and you've got a 4 over there, don't do this. Cancel it, put a 1 and put a 3 there. Be positive with the cross cancelling, but put the resulting answer down. And then, because you're going to take it again and again and again possibly, all right? It just precludes you from forgetting one. Thanks for watching, and I'll see you in the next session, and we'll carry on with Surds. Cheers, bye.